Hello, welcome to the second year engineering, computer engineering. The subject is computer graphics, unit 6, curves and fractals. Myself Dr. S.N.Gujar, professor in the department of computer engineering, TCSM, Bhirabai Sawant College of Engineering and Research, Nare, Pune, 41. Now what are the contents that we are going to cover today? So that is the curves and the fractals from the unit number 6. Introduction, what is meant by curve generations, interpolation, interpolating algorithms, interpolating polygons, B-splines curves and corners, Bezier curve, fractals and fractal lines and the surfaces. These are all the regarding the curves. And interactive graphics is what? Uses of the tools of the computer graphics in 3D Studio and then Maya. Now first comes the how you are going to generate a curve or any arc. So circular arc is the one of the part of our circle generated using DDA. So the DDA stand for digital differential analyzer algorithm. Now suppose I have considered any point, the center point x0, y0 and r as the radius. So now I am going to put the starting point and the ending point. So equation for an arc is the angle parameter as x is equal to r cos theta plus x0, y is equal to r sin theta plus y0. Means what? This theta is the angle that you are starting from x0 is going to add over here, r is the radius and cos theta is the angle. That's it angle you have to consider. x0 and y0 is the center of an arc. By differentiating, so we get the dx is equal to minus r sin theta d theta and dy is equal to r cos theta d theta. From the equation 1, r cos theta is equal to x minus x0, r sin theta is equal to y minus y0. Substituting above value in equations 2, so that we are going to form dx is equal to minus y minus y0 d theta, dy is equal to x minus x0 d theta. Dx and dy indicates the increment in x and y respectively. So x2 is equal to x1 plus dx is equal to x1 minus y1 minus y0 d theta. y2 is equal to y1 plus dy is equal to y1 plus x1 minus x0 d theta. Now d theta is the minimum value that you have to consider over here from 0.01 or 1 by 3.2 multiply with the x minus x0 plus y minus y0. Now so come for the DD algorithm, digital differential analyzer algorithm. So algorithm says the arc development. Read the center of the curvature x0 y0, what is the center point. Read the arc angle theta, how much angle you need. Read the starting point of an arc x0 y0 from where you are going to start. Calculate d theta, that d theta is equal to minimum value, that is from the 0.01 to 1 by in bracket 3.2 multiply with the x minus x0 plus y minus y0. Initialize the angle 0, while angle less than theta do plot, means that the put pixel x and y over here. x2 is equal to x1 plus dx is equal to x1 minus y1 minus y0 d theta. y2 equal to y1 plus dy is equal to y1 plus x1 minus x0 d theta. So this is the called as an incremental calculation x2 y2. Now angle is equal to angle plus d theta. Here you are going to complete this do, means that they repeat up to your completion of the angle, means while angle less than 0 theta, and then stop. Now come for the interpolation. The interpolation means what? If these techniques the curve is approximated by the number of the small straight line segment, it is possible to draw an approximation to a curve. If an array of sample points are known, then it can be a guess what is the curve should be the like between the sample points. Now what is the interpolation? See, the points are there. That's the points I am going to draw over there. The approximate value I am going to calculate, that's not going to passing the curve from the points. It is an approximator. It may be called as the interpolation. And the curve is going to pass exactly from the points is called as the correct points in curve. Fill in the portions unknown curve with the pieces of the known curve which pass through the nearby sample points. Since the known and the unknown curves share the sample points in a local region, it is assumed that in this region the two curves look pretty much alike. Now interpolations fit the portions of the unknown curves with the curve that is the known. So that is going to pass is the interpolation curve. Fit the region with the curve is called. Now fill the gap between the sample points. So findings the coordinates of a point along with the known approximations points. That is the known approximation curves. So these are the in between points you are going to calculate, and then join these points with the line segments or by the pixel segments is going to generate your curve. Now connect this all the points with the line segments, so that is going to generate your complete curve. So what is the technique for the mathematically? So to invent a functions which can be used for the interpolation, consider the polynomial curve that will pass through the n sample points. Suppose these are going to pass with the n sample points that I have considered in a space that is the x, y, z. These are the my point x1, y1, z1, x2, y2, z2 goes up to the xn, y1, yn, zn. Now we will construct the functions as the sum of terms. One terms of the each sample points. These functions can be given as a f of x u. These are functions of in the form of u. Summations that is going to come 1 to n xi bi u. Same for the y, same for the z. Now given 4 control points p0, p1, p2, p3. Space 0 in between u and 1v. P0, P1 is equal to 1 by 3, P2 is equal to 2 by 3, P3 is equal to 1. So these are the P0, P1, P2, P3 sample point. Now interpolation techniques is going to start then, that is the Pu is equal to C0, C1u and C2u square and C3u cube. Applying the interpolation condition 0, 1, 1 by 3, 2 by 3 and 1. That P0 is equal to CO and then C0 and then P1 is equal to 1 by 3. These are all the points we are going to put over there. So we can this matrix, from this matrix we can easily generate your interpolation curve. Now thank you very much for watching this video. That is my first video, that's from the unit number 6, that is the lecture 1. Thank you.